So you see it all the time, right? A new disease outbreak hits, and it just feels like total chaos. You've got news reports flying around, numbers changing by the hour, and honestly, a lot of confusion. But have you ever wondered how, behind the scenes, experts actually bring order to all of that chaos?
Well, it really all comes down to this one question. Think about it. Before you can fight a fire, you have to know how big it is and where it's spreading. It's the same in public health. So what is that very first, absolutely essential step you have to take?
You know, at first glance, an epidemiologist's job looks pretty straightforward. It's this simple three-step process. First, you count up all the cases, then you do a little math to calculate the rates, and finally, you compare those rates to see if anything weird is going on. Simple enough, right?
But here's where it gets tricky. That very first step, count cases, is hiding a huge challenge. Because before you can count anything, everyone has to agree on what exactly they're counting. What is a case? That one question, everything else hangs on it. And that brings us to the hero of our story, the case definition. You can think of it as the official rule book for a disease. It's a standard set of criteria that makes sure every single doctor, every lab, every health department is on the exact same page, counting the exact same thing. It's what turns chaos into data we can actually use. And we're not just talking about a simple label here. This blueprint, it gets super detailed. I mean, it's got the obvious stuff, like symptoms and lab results. But, and this is crucial for an investigation, it can also set very specific limits on time, place, and even the types of people involved. All right, so enough of the theory. Let's see how this blueprint actually gets used in the real world, specifically how it changes when we go from just keeping an eye on things, that's surveillance, to a full-blown outbreak investigation. Okay, check this out. This is a fantastic example using listeriosis. On the left, you've got your standard everyday definition they use for routine surveillance. It's pretty broad. But look at the right. That's the one they used for a real-deal outbreak investigation. See what they added? And that right there, that is the secret sauce. The outbreak definition gets laser-focused. By adding strict limits on time and place, investigators can filter out all the other random cases of listeriosis happening around the country and zoom in only on the ones that might be connected to this specific problem. Now, as we all know, the real world is messy. A diagnosis isn't always a simple yes or no, so the system has to have a way to deal with that uncertainty, which means not all cases get treated with the same level of confidence. It usually starts at the first level, with a case being classified as suspected. Then, as a little more evidence rolls in, that case may get bumped up to probable. And finally, when you get that rock-solid proof, usually from a lab, the case becomes confirmed. It's like climbing a ladder of certainty. And this table for measles, it lays it all out perfectly. Look how broad a suspected case is. Basically just a fever and a rash. Probable gets a bit tighter. But confirmed, that's the gold standard. You've either got a lab test that says so, or you're directly linked to someone who does. Okay, so that system works great when you've got a lab test you can trust. But what do you do when you don't? What if you're dealing with some mysterious illness and there's just no lab test for it? Can you even make a case definition then? Oh yeah, you absolutely can. And Kawasaki syndrome is the perfect example. There is no single lab test for it, so its case definition is built entirely on a clinical checklist. You need a fever for at least 5 days, plus at least 4 of these 5 specific physical signs. It just goes to show you can build a really strong definition based on careful observation alone. And that brings up another really important point. These case definitions, they're not carved in stone. They are living documents. They have to be able to change and evolve as we learn more, especially right in the middle of a crisis. Just look at the SARS outbreak back in 2003. This is like watching science happen in fast forward. The very first definition was basically just a guess based on symptoms and travel history. But then, just a week later, bam, they identify the virus and the definition gets updated to include lab tests. And it just kept changing over the next several months as we learned more and more. Okay, so we've seen how a case definition is a crucial scientific tool, right? But here's the final twist. It's not just about science, it's also about strategy. And this is where public health officials have to make a really big choice. It's a trade-off. Do you go with the sensitive definition, something really broad and loose so you can catch every possible case early on?
Or do you go with a specific definition, one that's super strict, so you are absolutely certain every case you count is the real thing?
So what does a sensitive definition actually look like? Well, for rubella surveillance, it's just any generalized rash illness of acute onset. That's it. I mean, that's going to catch a ton of other things, right? Chickenpox, measles, but that's the whole point. You're casting this huge net because you cannot afford to miss a single potential case. But then you flip the coin. For something like a salmonella investigation, you need to be surgical. The definition is super specific. Only lab-confirmed cases make the cut. Why? Because you're a detective trying to find the source. You can't be wasting time and money chasing down 100 false leads. So here's the bottom line, the big takeaway. There is no single best definition. The one that gets chosen is a strategic decision that depends entirely on the goal. Are you trying to ring the alarm bell as fast as you can, or are you trying to solve the crime? Because at the end of the day, the numbers are what tell the story of an outbreak. But those numbers, they're completely shaped by the definition someone chose to use, which kind of leaves you with this one big question, right? The numbers tell the story, but who gets to write the dictionary?